I'm Soundarya, working as Assistant Professor in CSM Department in Mlritm College. Today we are discussing about components of DBMS application and types of DBMS. Look at here, the components of DBMS application. So any application, it made to the 6 key components that work together and handle the data very efficiently. So here the first one is hardware, and second one software. Third, the most important here, the data and procedures and database access languages, that is DDL and DML, and people who are directly and indirectly involved in the applications. So this is the diagram of the components of DBMS application. We already discussed software is required for this one, and as well as hardware, procedure and data access languages, that is DDL and DML, DQL, TCL, like this, and people who are directly and indirectly involved within the applications, and data. So data in it is the structured way, otherwise unstructured way and semi-structured way data we consider here. And let's discuss briefly about the components. The first one is a hardware. Hardware is nothing but, we know, that is a physical device like servers, disk, input-output devices. Here input-output devices, as we know, that is keyboard, monitor, printer. By using of this one, we can give the input to the system as well as we'll get the output, and stores and processes that data, interface between the real world inputs as well as a digital system. For example, we can take computer hard disk and ROM. This is network devices used for the DBMS applications. So these are comes under the hardware of the components of DBMS application. Next one, software. See, after we having the hardware, we require compulsory software. So actually in the DBMS softwares, we like to MySQL, Oracle, PostgreSQL, etc. We can take any software related to the DBMS. It includes the database engine, OS, network software, and application tools. The translating database access languages into the operation. So we know the languages are DDL, DML, like that. And next one, data. So we have already hardware as well as software. So after these two, we required main thing as a data. So which application we are doing, we gather the data, either it is a metadata, otherwise a structured data and semi-structured data. So data is a raw fact stored in the structured or unstructured format. So operational data, that is actual user data. For example, name, age. If I am using student-based data, that is like it can take college applications, otherwise a university. So we require generally student name, student roll number, their age, like that. This information will be gathered here. According to the metadata, data about the data. In this particular data, the storage time, size, data type, everything will be involved. So actually we need, when we are gathering the information related to the student, we need to know about student name, their age, details, email ID. That is enough for to access the data. If you are considering that the metadata, when you are entering data into the database, it can also added the data types. Okay, when you are creating the tables, automatically it can access the data types as well as the size of the database, how much allocation places in the databases for the storage purpose. And next one, size and date. Because it is also considering the ISO dates. So this data is unnecessary to access when we are reading about the student. Okay, so that's why it is called as a metadata. And core reason for the DBMS exists, the managing and store the data efficiently. The major purpose of this DBMS application is we can insert the data and retrieve data from the databases retrieval. Okay, whenever it is not required, automatically we can delete data from the databases. And next one is the procedures. The instructions and rules for the using DBMS very efficiently. So whenever we are inserting the data, otherwise deleting, update, modify, whenever you are doing this data, we have to follow some rules and instruction. See, when I'm giving student entering data into the table, the student in terms of the character, I'm giving the data types in terms of the character. So I have only permission to enter the data in characteristics only. If I enter integer, it cannot be accessed because we are given the data type is the student is a data type as a character. Okay, if suppose I am student age, I can enter, I declare that age in terms of the integer. So automatically we can enter that age in terms of the integer number. Okay, we cannot enter float as well as a character, any string data, because that is an instruction when we are creating the data, that is in terms of the tables. And cover step, it covers the steps, that is a login and logout, data validation. We can also available the backup data, access control and report generation. So in this particular processes, when we have to log in into the database, we have to give the username, okay, and password, whatever we have kept it. Otherwise you can go for the create. While you are creating the database login details, we have to give a username properly as well as a password. And data validation, if it is having any time period, either it is a 3 months, 6 months, quarterly, half yearly, yearly. And backup data, whenever it is lost or restart, automatically we can go for the backup data is available by using of the processes. And we can also access control. So by using of the TCL, we can also give the restriction, that is a revoke and grant, which is the student can access the data which is necessary to access. We can give the permissions to that data access to the student, any others which is restricted, we cannot give the permissions to access the data. And help ensures consistent the security using the system. We can also providing security in the processes. And next one is the data accessing languages. So basically in the generally if two people are speaking, that is a communication by using of the different languages, either it is Telugu, Hindi, English, which is they're comfortable, they can express their communication. Here also we can access the data by using of DDL and DML, DQL, like that there are so many languages. We are using this language to communicate from the system, that is a hardware. In by using of hardware and software, we are communicate with the system, that the people who are required the data. So here we are using DDL, DML languages to communicate that. In the DDL, we can create the data and we can drop the data. We can create and drop the data and rename, truncate, okay, alter. We can go for the modify, which is needed for the table. And in DDL, in the DML, we can insert the data, delete data and update or modify data. Okay, na? So these operations can perform in these languages to access the data. So use it to interact with the database. We can create, read, update, delete the data. For example, SQL, MySQL and MyAccess, Archive, PL, SQL. So here we already know DDL is nothing but data definition language. Here we can create, alter, drop data and you can go for rename. We can also add here truncate. Okay. And next one is DML. DML is a data manipulation language. By using of this language, we can insert the data, update the data and delete the data. The next one is people. This is very important because who are directly or indirectly involved in this particular application, that is a people. User interaction with the DBMS at the different level. So from starting to end level, how the user, they can give the involvement. And data administrator. So this is the DBA he can manage the security and performance user accesses. So he can provide the security to the entire data, whatever having in the databases, DBMS, as well as performance, how much it performance giving, either it is a fast or slow, whatever the things happening in DBMS, they can provide entire performance by using of the DBA. And the next one is the user access. The particular person can can access this data by using of the permission of the DBA. So without permission of the database administrator, we can't access the data. If it is having access, we can directly access the data. Otherwise, we cannot access the data. So if you need any data, we can take the permission from the DBA compulsory. And the developers, the building application using of the databases. In the databases, we need this application built up. That is the data engineers who are application programmers, those comes under the developer. And the end user who are using the particular database, either it is a student, employee, any others, those can be access the databases. Okay, so this is about the component of DBMS applications. We covered here the first one, hardware, okay, and second one is software, and third, data. We need compulsory hardware, software, data, and next one is languages. So that is a database languages. Those are need to communicate with the system. And next one is people. Okay. And next one is processes. So these 6 are the components of database applications. The next going to the another topic, types of DBMS. So DBMS is nothing but database management system. So by using of this database management system, we can store the data. Okay, we can retrieve data from the databases. Okay, now, and we can delete, drop, or modify data by using of certain programs. So look at here, there are the several types of database management system, each tailored to different data structure, scalability requirements, and application needed. The most common types are the following. The first one is relational database management system, and second one is NoSQL database management system, Object-Oriented DBMS, Hierarchical database, and network database. So let's check in briefly. So coming to the first one is relational database management system. We can also call it as a RDBMS. The first one, the organizing the data in terms of the table. So look at here, the point is very important. The relation is nothing but the data completely in terms of the tables. Okay, and compose, that is a rows and columns. Generally, we know that the table is nothing but it contains certain rows and columns. Here, we can also give the primary keys and uniquely identify the rows and foreign keys to establish the relations between the table. So while using the primary key, we can access the data from one table to the another table. This is very important. And queries are written in the SQL. We can access the data or insert data by using of the structured query languages. That is the DDL and DML languages we can use to access and insert the data, and which allows the efficient data manipulation to retrieve the data also. For example, MySQL, Oracle, and Microsoft SQL Server and PostgreSQL. So these are the different types of the relational database management system softwares. Look at here, this is an example for the RDBMS. So RDBMS, we already know, the relational database management system. The relation is nothing but here, the table. So entire data we are storing in terms of the table. We can also call it as, this is the structured data. Okay, this is structured data. So in this particular table, we know general terms. This is a rows. These are the columns. 1 minute. Okay. In the table, these are the rows. Okay. In horizontally represent, those are considered here the rows, and the vertical, those are the columns. In the DBMS languages, we are called here, the columns are nothing but attributes. Okay. and rows are nothing but here the tuple. Okay, tuples. So whenever you are creating the data, these terms, these attribute names, we are created by using of the DDL. When you are creating the table, we can give the permissions to access the data. That is the student ID. So this is the data type is integer. So we can also give the primary key. So for this student ID, this is the primary key, and student name in terms of the character. Okay, now, and next one is the student age. This is the integer, and student class. We're also given here the integer. A student section, this is the character. So these are the instruction when we are creating the table. Okay, and we can also call it here the entity. Entity is nothing but the real world object. This particular entity contains certain attributes. Okay, now these attributes are we are representing in terms of the column. Here, the table represent the database entity. The data, the table rows is referred as a records or tuple. The table column as represented as a attribute. So here the database is nothing but the entity. We are storing this particular entity details in terms of the table. And second one is a NoSQL DBMS. NoSQL or NoSQL. Here, the data is completely in terms of the semi-structured or unstructured data. So previously we discussed the relational database management system completely in terms of the table, that is a structured format. But coming to the NoSQL, this is unstructured format and also semi-structured data. They are designed all handle large scale data and providing high performance for the scenario. The relational model might be the restrictive. When you are handling very huge data, on the time this NoSQL is very important, very useful to access and retrieve the data from the database management system, as well as we can easily store the data. Okay, and they store the data in various relational formats such as key value page, documents, graphs, or columns. So these are the different types of the data models in the NoSQL. These flexibility data models enable rapid scaling and well suitable for the unstructured and semi-structured data. So these data types are very useful in the semi-structured and unstructured data. The example for this NoSQL is MongoDB. So next one is Cassandra, DynamoDB and Reddy. These are the example for the NoSQL software. So look at this picture. So this is the difference. We are having two different types of the database. This is the SQL and this is a NoSQL databases. Look at here. In the SQL, the entry data in terms of the table, we can easily understand what are the attribute names here. That is a columns representation attribute name, and rows represent the tuple records, whatever related to that particular attributes data. So we can clearly understand the student IDs, names, and their grades and GPA. And coming to the NoSQL, this is also we can easily understand, but the representation of the data is different. That is not in terms of the structured format. This is semi-structured or unstructured data. Unstructured and semi-structured data. We are representing in the 4 different data models. That is a key value. By using of the keys, we can represent the values here, and documents. By using of document, we can store the data, and we can also represent the graphical way representation in the NoSQL, as well as a wide column. So here also it can also look like on the table format. So here we can call it as a wide column. Whether the data is present, the cells are represented in the dark color. If the cell is no value, automatically it will be represent the 0 value. So like that also we can store the data. So in the NoSQL database, we are having the 4 different types of the data model. The first one is a key value, and second one is a document representation. Third one is a graph representation. Fourth one is a wide column. So by using of these data model, we can store the semi-structured and unstructured data. Okay. And next one, Object-Oriented DBMS. Okay, so we know hoops through Java, the same hoops through Java, whatever the topics we covered, and we know polymorphism, inheritance. So same can be accessed here also. In integrated object-oriented program, concepts into the data environment, allowing the data be stored in the object way. Okay. However, we are storing the object in class and subclasses. Same way here also we can store the data in terms of the class and the subclasses. And this supports the complex data types and relationship, making the ideal for application require the advanced data modeling and real world simulations. So for example, for this object-oriented database management system, that is ObjectDB as well as DB4O. So look at this diagram. This can be represent the object-oriented database management system model. This is the class and these are the subclasses. So here the Ravi is a customer. Ravi having his name and that particular father name, otherwise the place name. Either it is a Ravi Yelu, and this particular Ravi contain the bank details and their particular address and another address. This is a permanent and present address. We can store the data in terms of the classes and objects and subclasses. Okay. The next one, the hierarchical databases. So we know hierarchical means parent and children. So organize the data like in the tree structure, where each record, that is a node, we can call it here, has a single parent. The single parent contains the multiple children. A model is similar to the file system. It contains the folder as well as a subfolder. It is efficient for storing the data with clear hierarchy, such as organization start and file directories. So navigation is fast and predictable due to the flexible structure. The lack of flexibility and difficult to reconstruct or handle complex, that is many-to-many relationships. So by using of this hierarchy, we cannot access many-to-many relationship here. So that is a disadvantages of the hierarchical database management system. So example for this hierarchical database management system is IBM Information Management System. We can also call it as a IMS. Okay. So look at the diagram for the hierarchical database model. So this is the electronic devices. So electronic device here, this is a parent node. We can call it as a parent node. This particular parent having the multiple children. So again, it is having the two children here. One is a television, second one is a portable electronics. Again, television is divided into the three children. One is tube, LCD and plasma. And here the portable electronics is again divided into the three children, that is MP3 players, CD players, two-way radios. MP3 player is again divided into the flash. So look at here, a parent node contain the multiple childrens, but here the children contain only one parent. So that is a different, and the disadvantages of this hierarchical model is we can't access many-to-many relationship here. So we can have a one-to-one relationship in the hierarchical model as well as one-to-n relationship we can access in the hierarchical database model. So this is a parent node, these are the children node. Every children contains one parent master. Okay. And next one is a network databases. So here network database, we can use graphical representation model. It allows more complex relationship between the entities. And unlike hierarchical model, it permits each children have multiple parents, enabling many-to-many relationship. So whatever we are having the disadvantage in the hierarchical model, that is the advantages in the network model. The data is representing using the records and sets, where the sets define the relationship. So we know that is one-to-one relationship, cardinalities rules, one-to-n relationship, n to one to many, many to one, or many to many. So these are all representation relationships can be accessed in this network model. The data is represented using the records and sets, where sets is defined in the relationships. It is more flexible than the hierarchical model and better suits for the application with the application data linkages. So comparing to a hierarchical data model, this is very flexible. We can access and store the very complex data also. Example for this network data model, integrating data store, that is IDS and turbo image. So look at the diagram here, the network DBMS. So this is the store. This particular store contain customer, manager and salesman. So this is the parent node here, you can consider, but we don't talk here the parent node. Okay, the network, these are the nodes. This particular store having the three children, that is a customer, manager and sales. And this again the customer is connected to the order, and order is also connected to the manager and salesman. So here the children contain many parents. Okay. So in the hierarchical model, every children contain only one parent, but here we have the multiple parents. And items have connected to the salesman, only one. Okay. But this particular order contain the customer, the manager and sales. Okay. What we covered today's section, the first one is a components of DBMS application. We're having the 6 types of the components here. The first one is a hardware, software, data and people, procedure and database, access, languages. Okay now. So these 6 components are very useful to access the data, retrieve the data, application performance very easily. And second one is the types of DBMS. Here we are having the 5 different types of the database management system. The first one is Relational Database Management System, that is a RDBMS. Here enter data in terms of the structured way. We are storing the data in terms of the table. Okay. Here rows are called as the records or tuples. Columns are the attributes. And second one is NoSQL. So here we can store the data in terms of the semi-structured way and unstructured way. Okay. And next, third one is Object-Oriented Database Management System. Here we are having classes and subclasses data we can store here. And next one is a Hierarchical Database Management System and Network Database Management System. So in the Hierarchical Database Management System, we don't have many-to-many relationship. It can be overcome in the Network Database Management System. Okay, this is a brief introduction, brief contents about the today's section. And these are the references, whatever we have covered the topic today. Thank you.